Right. Good day once more, good people. Let us continue with our Claisen condensation. Right. Now remember, in the last class we said whenever we are carrying out a Claisen condensation, or rather a Claisen condensation, it's all about, right, reacting two what you call like esters, two ester molecules together under these conditions to generate what we refer to as what? As a beta keto what? Ester. As a beta keto ester. Right? As a beta keto what you call like ester, so to speak. That's what the Claisen reaction is all about. Now, in terms of the mechanism, how does this reaction actually take place? Right? Now, let us look at the mechanism. Right? Now, students tend to have a problem. Once you mention the term mechanism, their minds just close. Right? Then they become too scared. Students, do not be scared of the term mechanism. All that the mechanism is all about, it's all about showing you the movement of electrons. The movement of electrons, where we use what? Arrows to show the movement of electrons. A full arrow means a movement of two electrons. That's very important. You see? Now, I'm going to show you, right, how we do mechanisms. Right? Let's proceed. Now, in this case here now, like, what's going on here now, like, is there's my, what you call like, my starting material, pH, bonded to CH2, double bonded to oxygen, 1, 2, 1, 2, and then there's my OET in that case. So, this is my ethyl ester. So, before I proceed with the mechanism, then I must go to my functional groups, right? And go and observe and go and see and go and question the chemistry behind that particular functional group. For example, now, like, if I look at this here now, like, what is it that I see? Here, I see oxygen. That is the, what you call like this oxygen atom that is seated here, right? Now, I know that like oxygen in the periodic table is much more electronegative than your carbon atom. And therefore, by inductive effect, this oxygen, it pulls the electron density towards itself. Now, the electrons will be moving towards oxygen. And when they do that, oxygen will assume a sigma negative state, right? As we have already seen with aldehydes and ketones. Then this carbon atom, in this case now, like, will become or will assume a sigma positive state. Now, once that carbon becomes electrophilic, now it means that now, like, the neighboring carbon atom or the carbon atom in the alpha position, right, will release its electron density. Will release its electron density towards what? Will release its electron density towards this electrophilic oxygen, what called, I mean, like carbon atom in this case. And when it does, remember this carbon atom here, in this case now, like, there are two hydrogens that are attached here. There's a hydrogen here and there is a hydrogen here, right? So it means that now, like, right, when these electrons are released towards the electrophilic, what called like carbon atom, then this carbon becomes positive in charge. And this carbon atom, it's the one that draws electrons away from this hydrogen, the alpha hydrogen atoms. Right? Alpha hydrogen atom in this case, right? Right? Now, meaning that now, like, this hydrogen can easily fall off, right? And be easily picked up by what? By a base, right? Now, in this case now, like, the base that we have, right? Okay? The base that we have here, the base that we have here, the base that we have here, it's our sodium ethoxide. So, we are having sodium ethoxide as our base. That is my number one there now. Now, there's my Na plus O, 1, 2, 1, 2, 1, 2, negative Et. We have chosen this base because here we are dealing with an ethyl what? Ethyl ester. So we are using this sodium ethoxide. That is the reason why we've chosen that. Now, what then happens is that now like this ethoxide, it comes in here as a base to come and pick up this proton. Now, this hydrogen here leaves behind the bond pair that it shared with this carbon atom, right? Now, look at this now, like we are using full arrows, meaning a movement of 2 electrons, right? So, in a nutshell now, like hydrogen leaves behind 2 electrons here. Then what do we get here now? We end up with hydrogen, only 1 hydrogen atom now, in that position. There's my pH. This here, this double bond O, 1, 2, 1, 2. This is my OET in that case, 1, 2, 1, 2. Now, that hydrogen has left 2 electrons, in this case, in this carbon atom, which is minus. So, it has generated a carbanion, carbanion. That is, it's an anion, right? Where the atom bearing the charge is carbon. Then with this we call it what? A carbanion. So this is what we generate here, right? Now your OET, that side, with that hydrogen, it's going to form ethanol, right? As your byproduct in that case. Now, this is the carbanion like that we have generated. When we look at this carbanion, we see this carbon atom bearing electrons, right? And there's a single bond here, and there's a double bond that follows. So it means that like there is some form of conjugation there. So there will be a mobility of what? Of your electrons, right? So your electrons will move, right? Because of the conjugation pattern that we have there in that case. So as these electrons are drawn to form a double bond here, carbon here can never have 4 bonds. Then this bond here, it breaks, releasing those electrons to what? To oxygen. Then what do we generate? We generate now like a structure that we refer to as a what? As a resonance structure. There is the structure that we form in that case. This here, there's now a double bond in that case. There's my oxygen, 1, 2, 1, 2, and this oxygen now like has gained 2 more electrons, right? From the breaking of that bond, then it becomes negative, right? And then that side, we have our OET, 1, 2, 1, 2. Then there we still have our hydrogen. Now, this here I'll put brackets because these are my resonance hybrid structures. So in this case now, like I have generated my enolate in this case, right? My ester enolate, right? So in this step, now for me to proceed now, I will choose this one, right? The carbanion, whatnot, like intermediate, enolate in that case, right? To go into the next step. There we go. H bonded to what here? There's my pH here. This double bond O, 1, 2, 1, 2, and then there's my OET, that side, right? Now remember now, like here, what we have here now, like we have a carbanion on this carbon atom. There's my negative charge. And then now, like, I will go and take the second molecule, right? There's my second molecule. My second molecule is pH bonded to CH2, bonded to this, doubly bonded to this, and OET. There we go. There we go, right? Now again, it's still the same chemistry. Oxygen, right? By inductive effect, has got more electron density towards, it's more electronegative than carbon, then it pulls the electron density towards itself, rendering this carbon here electrophilic. Then it can easily be attacked by what? By this carbanion in that case. As that happens, right, then these electrons here are going to be pushed to what? to oxygen in that case. Then what do we form here now? What do we form here now? Like we generate, this is how I'm going to write it. I'll start here. There, we've got pH, in this case, bonded to CH2 here. CH2 that is bonded to oxygen, 1, 2, 1, 2, and the 2 new electrons here, 1, 2, then there will be a charge on this oxygen now, right? And then this oxygen here is bonded to what on that side? To OET, 1, 2, 1, 2. And this carbon atom now like has got a new bond with this one. I will write that new bond as red. There's my red, right? So there's this carbon atom here. That is this carbon atom here. This carbon atom here is bonded to what on this side? It is bonded to pH that side, right? And bonded to what up there? And bonded to hydrogen there. That is to hydrogen that side. Then on this side, it's also bonded to what? It's bonded to a carbon atom that is doubly bonded to oxygen, 1, 2, 1, 2. And there's my OET there, 1, 2, 1, 2 in that case. So I end up with this intermediate. Now what's going to happen now like with this intermediate in this case now? This intermediate here in this case, this oxygen will bring back the bond pair, right? To reform the double bond in this position, right? Now as it does that now like this blue OET in this case, it loses, it takes away the bond pair. It becomes a good living group. It becomes what? A good living group. And then like it leaves, right? Now next step, what do we form here now? In that case, we form here, that is in this position, a pH. I'll write it here. pH that goes to a CH2. There's my CH2. That goes to a CH2. This side here, it goes to a double bond O here. 1, 2, 1, 2. Right? Now the OET is no longer there. The OET now like has been replaced by what now? By the red bond. There's my red, what call I bond to this CH. There's a CH here. And then this CH here. Then there's also a pH there. There's my CH. Then there's what here? There's pH and a hydrogen. I'm not going to write hydrogen now because I'm using line and the formulas, right? Then this carbon atom here now, like it goes to what? It goes to a C double bond O, 1, 2, 1, 2. And then that side, it goes to what? To OET. It goes to OET, right? Now, what else have I formed here now? As my byproduct in this case, I have formed my OET minus. OET 1, 2. That is the one that left. That was expelled as a good living group. There we go. Negative. Right? So this is what I form here now. Right? Now if you look at this now, like you can automatically tell that like now like this is our starting material. Yes, this is our starting material. Right? I am supposed to stop here, but I cannot stop here because there is a challenge that this target molecule has here. Yes, this is our target molecule, but the formation of our target molecule in this case, right, has also led to the formation of what? Of your ethoxide in this case, right? Now the presence of that ethoxide is a challenge for the target molecule. I'll show you like in the next class now, like what is it that I mean or why is that the case? I'll answer that now like in the next class, right? For now, I would like to thank each and everyone who has subscribed to my channel, and also thank each and everyone who has viewed any of my videos. Thank you very much, right? And also anyone who has shared my my videos, right? I would like to thank each and every one of you, and I would also urge all those who haven't yet subscribed to my channel to do that, right? All of you are giving me what? Support. You guys are supporting me, and I am very much grateful for that, right? I'll see you in the next class. Remember, organic chemistry is easy, organic chemistry is beautiful, organic chemistry is fun, and you guys can do this organic chemistry. Thank you very much. I'll see you in the next class.